So I've seen a couple of questions on the Discord about how this actually works, like about how all of the different parameters work individually. So we create a new 2D parameter to see the parameters. Let's start with the pendulum. The gravity scale is very simple. Like, we can swing it around like this, and if we increase this to like 5, it will get a lot springier, like it will get pulled to the middle a lot faster. And we can even increase this, I don't know, 16. Like, this is very rigid, as you can see. I believe if you're fast enough you can still affect it, but yeah, that's what the gravity does. Length is, in my opinion, the most important variable to change. Usually I fit it to the length of the part that I want to move. That way it makes a lot more sense together with the movement of the part. So, I mean, it's also pretty straightforward. Like, this is 200 now. We can still increase the gravity and it will have the same stiffness effect. Now the resonant frequency. This is a parameter that only works on the spring, similar to the gravity. So currently it's a normal spring that bounces up and down. If we increase it to like 10, it's very stiff. And on the other hand, if we decrease it to like 0.1, it's still a spring, but it travels very slowly. Same with the gravity scale. If we set it to 0.1, let's set this to 1 again. It's moving a lot slower. The damping, the first parameter affects the pendulum. So if I increase it to 1, and let's set the stiffness very high. So if I increase it to 1, it will always fall back, but it will only fall back to the original position where it's pointing straight down. So, hold on. This is actually affecting the pendulum too. There's no way, right? No. Yeah, that... Okay, yeah, I was right. Now if you have a spring pendulum, apparently the spring affects the movement too. Interesting to know. So the damping on 1 means that, yeah, it will always move slowly back to the original position. Values below 1, like let's go extreme 0.2, will lead to an overswing. So if let's get this back to a pendulum. If I swing this, you can see it will overcorrect and swing back and forth. And values higher than 1 will simply just lead to even slower descents back to the original position. Okay, so the second damping parameter affects the spring the same way the first one does the pendulum. So if we set this to 1, it will simply slowly go back to the original position. and any values higher than 1 will just lead to even slower like going back to the original position. And values lower than 1 will mean that you will bounce back and forth a lot. So let's reset this to 0.5. The output scale is only relevant for the parameter outputs. So currently we go from -1 to 1 on both axes, and 1 will always be correspondent to the length. So if I have this to xy, right? Hold on. Oh yes, a spring pendulum. I want a pendulum. Okay, if I have this at xy, 1 to 1 means that for a pendulum, the value will always be locked to like the semicircle from like this corner all the way over the middle to this corner. And I mean, you can see that. So with a pendulum, you won't need the bottom part, just like 1 to 0 on the y-axis. When you have a spring pendulum, you run into the issue that you're no longer just restricted to the length. So this can lead to you going out of bounds, depending on how stiff you have the resonant frequency. And if we set the length back to 100, the standard, you can see that the default values, if you keep them in every parameter, that you will easily just jump outside of the parameter. So I would recommend, if you use a spring pendulum, to increase the size of this box and also increase the length, so that the change in length compared to the overall length is a lot smaller. The next thing I would recommend you to do is figure out where you want all your key points based on the normal output scale. So if I have a pendulum that swings like this, I might want to set the key points just in the default parameter. If I of course move very erratically, I might want to increase the hold on. I might want to increase the the constraints of the parameter so that I will still stay inside of it. After you have set all the key points and it looks pretty good, then I would start fine-tuning with the output parameter scale, the output scale, so that so that you can like make it a little bit more how you want it to be. I wouldn't set the output scale to values like 30 or something. I don't see the reason. It will be mapped onto a parameter anyway. So why not just keep it at 1, keep everything here at 1, except if you maybe want to like set it to the length and then have the parameter also the length. It just doesn't make sense. Keep it at 1, set all of your points at 1, and afterwards fine-tune the output with this with the scale. And now that we understand how to make these things, we can make some real-life. We can imitate some real-life examples. Like, for example, if we have something like the door springs. Let's see, door springs. Door stopper spring. Yeah, if we want to model something like this, right? We know that it is it goes back and forth very fast. So we need to increase the gravity scale. Let's set it to, I don't know, maybe 10. Actually, let's set it to like 5. So now it's a lot stiffer. And if we set the damping to like 0.1, we now have something like the door stopper spring. Or if we want to imitate like a very slow moving cloud, we can... What was that? Nothing. Okay. We can set the gravity to like 0.2, the resonant frequency to 0.2. I would usually keep these two very similar, unless you have like special cases where that's not required. And the damping I would set to a higher value where we don't overcorrect, to 1 in both cases. Let's get the original output scale. You can see yeah, always make sure that if you have a spring pendulum you don't accidentally have like stuff where the length gets too short, because that will cause kind of weird behavior. But as you can see, we have like a cloud that is slowly trailing behind the actual like that's slowly trailing behind the root node. Well, not the root node, I guess the actual coordinates of this thing. Oh, also there's this button, local transform lock, which means if you have this inside of a node and the node moves, the physics won't move. Hey Kaiser Blue, how's it going? Let's quickly go over the mapping modes. These are always X and Y on the parameter list. So you can have a one-dimensional parameter where you have just the angle, just X, just the length, or just Y. Or a two-dimensional parameter where you have angle and length on X and Y, or X and Y coordinates of the point, and so on. Going over to you, well, people have been asking how to do physics on a Discord, so I'm now explaining it. Also, very funny bug. I don't know how this happened, but when I use my graphics tablet to move my mouse, you can see my mouse, right? Now if I remove the pen from the tablet, it just disappears. I can still like the cursor still exists, but I can't see it. And this only happens in Inochi Creator and Session. Other programs are completely fine. But for some reason here I have to use my tablet so I can actually see my mouse. Thank you for watching the video. If you liked it, please leave a like. If you have questions, leave comments. And subscribe if you like my content.